This is the first video from section 1.1 from the notes. And in Calculus 3, this is the first course in the calculus sequence that we acknowledge the fact that we live in a three-dimensional world. And so in Calculus 1 and Calculus 2, you drew the xy plane, you had an x-coordinate, you had an x-axis and a y-axis, and every point had an x-coordinate and a y-coordinate. Here, in Calculus 3, we're going to work in three dimensions. So we have three axes, an x-axis, a y-axis, and a z-axis. So let me explain the axes. This is going to be a little bit easier when I'm actually in the classroom with you, so I will probably repeat this on the first day that you're in class. But here is a picture of the room, or I should say a sketch of the room. Here's the floor. This is where the board is. So imagine you're sitting in the room and you're facing the board. This axis here, that's traditionally the positive x-axis in two dimensions, is the positive y-axis. So this is the positive y-axis. The positive z-axis runs along the corner of the room. It goes from the floor up to the ceiling. And it keeps going through the ceiling, but that's the positive z-axis. The positive x-axis comes out toward you. So here is a wall, and then here is another wall. And so the positive x-axis comes out towards you. The negative x-axis is on the other side of the wall. The negative y-axis is on the other side of the other wall, and the negative z-axis is below the floor. So this is the three-dimensional coordinate system. And I'm also going to look at part A of example 1. Part A of example 1 is to plot the point 3, 1, 4. Now, plotting a point with three coordinates on a board, you're trying to plot something three-dimensional on a two-dimensional surface. So we have to basically draw an optical illusion and give this the appearance of depth. And so, first of all, I start by drawing the y-axis and the z-axis because they're the easiest. They're the traditional x and y axis from two dimensions. So draw the x, draw the y, and then you draw the y, draw the z, then you draw the x. I do this at about 45-degree angles through here. Put your hash marks along the y-axis and the z-axis the way you normally would. For the x-axis, make these things perpendicular to the x-axis. And so we want to plot the point 3, 1, 4. So find those points on the axes. So 1, 2, 3. So we come out and we find the point 3, 0, 0 on the x-axis. And if we come along here, we come along 1 unit. So this is the point 0, 1, 0 on the y-axis. And for the z-axis, 1, 2, 3, 4. So we plot the point 0, 0, 4 on the z-axis. And to find the point 3, 1, 4, now we're going to draw a rectangular prism or part of a rectangular prism. To do that now, draw lines that are parallel to your axes. So for example, we found the point, let's see, right here. So here is 3, 0, 0, here is 0, 0, 1. So we're going to draw this line that is parallel to the y-axis. This line is going to be parallel to the x-axis. These two lines, draw these until they meet. So this now is the point 3, 1, 0 on the xy plane. So if you're thinking in three dimensions, this is on the floor of the room. The same thing here. So we have our point 0, 0, 4. We draw this line here parallel to the x-axis. So we draw this parallel to the x-axis. This line is parallel to the y-axis. This line is also parallel to the x-axis, and this should be parallel to the y-axis. And so that's how we draw this box. And so now we have the point 3, 1, 0. We come up here. This is the point 3, 1, 4 that we're looking for. I drew in some other points that we weren't necessarily asked to find. So This is 300. I talked about this. Come up 4 units. This is 304. Let's see. And we have 310. So I think I talked about that. 3, and then for the 1, so this is 310. We come up, this is our 314. I will draw the other 2 points in the next video.